So, careful. I don't intend that to trip people, but it does fall down. All right. So there's a few questions on 3.4 that ask you to find the domain. So we're finding those x values of these functions. When we're talking functions, we are talking real values. We're not doing imaginaries on functions. So we're looking at these and trying to figure out how we need to have our x's be in order for this to be real. So on this first one, with square roots, what do they need to be in order for them to be, real or not imaginary? So what's under the square root needs to be what? Positive. Or at least not negative, right? So I need, for this thing to stay a function, I need this chunk to not be negative. Bless you. This guy needs to be not negative. Could it equal 0? Yeah. So I need this piece for my domain, my 4x minus 1, to be greater than or equal to 0, right? Because it doesn't have to be the square root part. You're just making the other part of that. All I care about is that thing under the radical. I need that to be greater than or equal to 0 in order for my function to live in the world of real numbers. So what are my x's going to be? How do I get my x by itself here? More specific. Solve, yes. More specific. Add 1. 4x greater than or equal to 1. And then divide by 4. So my x's need to be greater than or equal to 1/4. How do I write that as an interval? So it's like, think of it like our number line thing. So if I draw this on a number line, we'll put a closed circle at 1/4, and we're shading where x is bigger. So this way. So this is going to go from 1/4 to infinity. Infinity always gets a parenthesis. How about our 1/4? Bracket, because it's got that equals to.
Why do we use the greater than or equal to sign?
Because it's okay if I have a 0 under the radical. Totally fine. Square root of 0 is 0. We can do that. We just can't have negatives under there or we get imaginary numbers. So my x's can be anything that makes my radicand, what's under the radical, not be negative. So it can be anything from 1/4 and bigger.
So if the equation starts off negative and you switch it up with a sign to make it sure it's not negative on the radical?
We're solving to figure out what, when under the radical, is going to be positive.
Why is it? No.
Okay. We'll have the radical come up again, I promise. On the third one. So we'll practice the radical things again. There's another kind. This middle one, we've got 3x squared over x squared minus 1. So we want to make sure we wind up in the world of real numbers. They don't have to be pretty, they just have to be real. So is there anything in my numerator that would cause us to have anything that was imaginary or undefined? Is 0 in the denominator is a problem, not in my numerator. But in the denominator, that's a problem, because that gives us undefined. So my numerator actually doesn't really matter. It's not doing anything for or against me, because it's an x squared, and I don't really care. What we care about is when is our denominator equal to 0. So we cannot have, not the button I meant. I got it. So this piece cannot equal 0. What's up? Clipboard should be passing around. Keep moving the clipboard, guys. It needs to pass around because we need everybody to sign it before the end of tomorrow. It's moving. tomorrow I'm going to start it from this end, so make sure it gets to you guys too. So I have a plan. Today I started them over there. Tomorrow I'm starting them over here. Okay, so we need to figure out when that denominator does equal 0 so that we can exclude it from our domain. So I'm going to set it equal to 0 to solve, but those are our excluded values. So I'm going to solve when x squared minus 1 equals 0 to find our excluded values, the places it cannot be. So what are we going to do to solve this? Add 1. So we get x squared equals 1. What is x going to equal? Plus or minus square root of 1. What is the square root of 1? 1. So my domain cannot have positive 1 or negative 1 in it. It can be absolutely anything else in the existence of the universe except 1 and negative 1. And if we were writing it, algebraically, that's really easy. Real numbers except x cannot equal plus or minus 1. However, we're doing intervals. So it's going to be obnoxious.
Are you going to do that to both the top and bottom?
The top actually doesn't make any difference because if the top is 0, we just have 0. It's only when the denominator equals 0 that we have a problem. So the numerator can be whatever the heck we want it to be. It can be gross, it can be pretty, it can be 0, it can be negative. It won't be negative because x squared would be positive and 3 is positive, but it could be. Doesn't matter. My denominator just cannot equal 0. So if the number line helps you, sketch it out. I could have absolutely anything except for negative 1 and positive 1. So if I sketch this as intervals, it would look like this with open circles at negative 1 and positive 1. And it can be anything else. Absolutely anything else. So not going to be word brackets. We're going to do 3 little intervals. Because I have a hole. We have to be able to jump over it. And on interval notation, that means we stop, jump the hole, and then do a new interval. And then we stop, we jump the hole, and do a new interval.
For the first one, why did you put less than greater than equal to?
Up here?
Yeah.
Woo, that was not the laser pointer. Here? Because if we have a negative under the radical, we get imaginary numbers, which is not what we want in a function. We only want reals. So here we're going to do 3 separate intervals. So this piece, how can I write this piece as an interval? From negative infinity to negative 1. Infinity always gets a parenthesis. Open circle on negative 1 means parenthesis. Then we need to do the in-between interval. So we're going to go from negative 1 to positive 1. And we're going to go from 1 to infinity. And all of these get union together.
I have a question.
Yes, dear?
About back to the first one.
Yep.
Greater than or equal to.
Yep.
So if there is a negative, like a minus sign under our radical, we're going to set it to be the equations to be greater than or equal to 0.
Still the same thing. We still need our radicand to be positive. So we still set it greater than or equal to 0.
Okay.
I need the statement to be positive. So speaking of radicals, let's look at the next one. I have another fraction. So again, my numerator is not a big deal, but I need my denominator to not equal 0. And in the radical, I need that to not be negative. I don't want imaginaries either. So we have we're going to kind of combine the last 2 pieces together. This chunk needs to not equal 0, and my 2x plus 6 needs to be positive. So we're going to set our 2x plus 6 with what relationship to 0? Can it equal?
No.
No, so just greater than. So we're going to have our 2x greater than what? Negative 6. So our x is greater than
-3.
negative 3. 6 divided by 2.
Oh, yeah.
It's okay. We've been thinking a lot of really hard things, and when I toss an easy one at you, we sometimes go, wait, what? Derail your brain a little bit. As an interval, negative 3 to infinity. Parentheses on both because it's a greater than, not greater than, or equal to. Okay? Questions on these three? One more type of question. Last one. One. Okay? Because sometimes in the homework they're going to give you a difference quotient and a number. That's our difference quotient. We did it before with f of x plus h minus f of x over h. We did it not yesterday, but the day before, when we did our like f of a minus f of a, f of h, that guy. It's the difference quotient. They give it to you. They show it to you. You like it's not a thing we need to have, but it is a thing that will come up in higher math repeatedly. You use this in calculus a bunch for particular situations. We're just practicing with it now. So what we have here is we have a gigantor fraction that we are going to be doing some substitutions in. So I'm going to set this up as a gigantor fraction, and we're going to start doing our substitutions. Because in our first piece here, we're substituting in 2 plus h in place of all of our x's. So I'm going to take my f of x and substitute in that 2 plus h. So we're going to have 2 plus h quantity squared minus 6 times 2 plus h.
Why is it quantity squared?
Because I'm putting it into this function here. So I'm putting my 2 plus h in place of this x.
Okay.
And then I'm putting my 2 plus h in place of this x. We're substituting in the 2 plus h in place of x. And we're then going to subtract f of 2. So I'm going to substitute the whole thing in. F of 2 is 2 squared minus 6 times 2. It's a substitution thing, and it's all over h. We've worked with this with x's and h's and a's before, and for some reason when they start throwing numbers in here, everyone just goes, wait.
So you split up the negative 6 and the square of x squared. Why'd you do that? Instead of splitting it outside.
Word it again. Say it again.
The f of x equals x squared minus x, or 6x.
Uh-huh.
Where did you incorporate that at? Why did you split it up like
So this is f of x. We took my 2 plus x, or 2 plus h, and that went in place of x here, and in place of x here. So this is x squared minus 6x.
Oh.
We just substituted. And this is again x squared minus 6x. And I substituted the 2 in for x here. So I used my f of x, but this is f of 2 plus h. This is f of 2. H. Okay, so substitution. Multiply it out. Simplify. Okay, we have like a minute. So, yeah, it's 35. So the setting up is the hard part on this. Y'all can square stuff.
All of h is going to be one. It's going to be math.
We can square stuff. 2 plus h, quantity squared. Box, distribute, whatever we need to. Distribute the 6. 2 squared is 4. 6 times 2 is 12. Simplify. Do the things. I will finish the simplifications and get it posted at the PDF of the notes. I don't remember. Okay, I will get it posted here within the next 20 minutes. This is 3.4. Still on 3.4. Still on 3.4, yes. We've been on 3.4 pretty much since Tuesday.
We put 3 It's like probably due tomorrow, isn't it?
Technically, yes. Okay. Get in as quickly as we can. I honestly don't remember because I did a different one in third period because I wanted to make sure we caught one with a number. So I'm going to finish it and get it onto the slides. I recorded this class so that I can get this one up there that has the number in it. Because in third period, we did not do with the 2. We did an x plus h. And to be fair, that was even worse.
Oh, Miss B.
Yes,
You want me to just sign that tomorrow?
Yeah, that's fine. I'm going to pass it around tomorrow as well. Yeah, I'm going to pass them around tomorrow. What's up?
How you do credit for this dual credit class? Is it only for this class?
What do you mean?
Like, if I